Hi, my name is Peter, and today I'd like to tell you more about a debug tool that I've created called STM Viewer. If you haven't heard of it, STM Viewer is used to visualize your embedded targets variables in real time. So basically you can plot these values on a time plot or on a bar plot, and you are also able to modify the values on the go. So in today's tutorial, I'd like to show you how to set up a simple project and plot some values using STM Viewer. So let's dive right in. After installing STM Viewer, you're going to see a screen like this. On the left hand side, you can see a control panel, and on the right hand side, you can see the plot canvas. First thing you want to do is to go to the options and acquisition settings and select the ELF file of your project. In this case, I'm going to use the template project from STM Viewer repository. We'll also select these two checkboxes, which will ensure that whenever we rebuild our project, the addresses of the variables are going to be refreshed automatically, and the acquisition is going to be stopped so that the debug probe is released when you want to download your binary file to your target using your IDE. The sampling frequency can be left at 100 Hz. The maximum amount of points is basically a value that if you go above, the oldest points are going to be deleted, and the max viewpoints is the amount of points visible on the screen during acquisition. The more points that are visible during acquisition, the slower and the more laggy the UI gets. So if you see any performance issues, ideally you want to dial it down. The debug probe section is the next section that we're going to take a look at. In this tutorial, we're going to use the JLink probe, as this is what the latest update was all about. As you can see, I've got one JLink probe connected to my computer. It detected the serial number automatically. The SWD speed that we're going to use is 1 MHz, and the target name is STM32G474CC. We're going to also switch for the highest speed sampling mode, which is a mode that allows you to reach the highest sampling rate. It's not needed for this tutorial, but we will just show that it works. Alright, so at this point we are able to import the variables from the ELF file. And as you can see here, we've got a list of the variables that were detected. What is important that these variables cannot be local, so they have to persist throughout the whole lifetime of your project. We'll select these four and we'll click import. When I click done, the addresses are updated automatically, and we can drag and drop some variables onto the time plot. Basically now we're ready to start the acquisition. So as you can see, these are just 3 sine waves. It's a pretty simple example, but what I wanted to show you is that you can also write values. So we'll create another plot of type table, and we'll drag and drop the amplitude variable. And basically in the code, the amplitude depicts the amplitude of these 3 sine waves. So whenever I change it on the fly, you can see that the output of these 3 sine waves also changes. This can be useful to control the flow of your program from the STM Viewer itself. Alright, so we also have the bar plot, which is useful when you don't really care about the time, when you only care about the value of the variable. And you can also run some simple analysis after gathering the data. So we also have markers that can be used to check the time periods between 2 points from the signal that was gathered. Or if you're interested in a little bit more advanced feature, there's a statistics window that shows some features of the signal within a selected range. So this is how it looks like. And of course, if you want to perform a analysis outside STM Viewer, you can always export the plot to CSV and carry on outside the program. Okay, so I think this is all for this tutorial. I hope it cleared some things up, and if you want to, you can visit STM Viewer on the GitHub page. Feel free to leave any comments or suggestions, and yeah, happy debugging. Goodbye.